we repeat the process then. We draw a ray from the very top of the object through the centre of the lens. We'll just continue that on. Remember, we must put an arrow on the ray. We then draw a ray that is parallel to the principal axis to meet the lens, and then it moves from the lens down through the principal focus and again where the rays meet we can draw the image. And this image, as with the previous example, we must identify 4 different aspects or properties of the image. The location of the image in this case, the object is between 2f and f, the image is beyond or further away than 2f. Also, what we notice is it's a real image because we can capture it in a screen, and we've done this in practicals in class. It's inverted. And in this case, if we were to measure it, it's larger than the object. Or we could say that it's magnified. So we have a real, inverted, magnified image that is further away from the lens than 2f. And we find in this case that again we have a real image because we can capture it in the screen. It's inverted, and in this case its location is at 2f. So if the object's at 2f, the image is at 2f. It's real, it's inverted, and when we measure these we can find that it's the same size as the object. So remember that in each case you're making 4 points about the image: its location, its nature, whether it's inverted or upright, and its size. And in this case it's at 2f, it's real, the same size as the object, and inverted. Now this application where we have the object closer to the lens than f, this is typical of the question that you would expect to see in the exam, because it's the exception in that in this case we get a virtual image which is located on the same side of the lens, the same side of the lens as the object. Now, how do we know this is going to be the case? Well, we draw a ray from the point of the object through the centre of the lens and out the other side. And then if we draw the one that's parallel to the principal axis and through the principal focus f, we will find that we have diverging rays. In other words, they're moving apart. So no matter how long we continue these rays, they will never converge and meet to give us an image. But if we take then and extend the rays backwards on the same side of the lens as the object, we will find that they do converge. And unfortunately in this case it's in the middle of the writing. But they converge at a point to the left of the lens, in other words on the same side of the lens as the object. And because we are continuing these rays backwards, this forms a virtual image. We can't capture this image on the screen. Therefore, we must use dotted lines to show the virtual image. I know that's difficult to see with the writing there, but it illustrates the process. In this case, the image is on the same side of the lens as the object. It is a virtual image because we can't capture it in the screen. And also it's upright. Previous images we had were all inverted. This one's upright and it's larger than the object. So we have a virtual image on the same side of the lens as the object, and it's upright and larger than the object. In other words, magnified. And this is the principle of how a magnifying glass works. It produces a virtual image, and we can see which produces a magnified image of the object depending on the location of the object. So take some time now, turn off the camera, or turn off the video, and answer these questions yourselves, and then check the video. So to summarise then for the lenses. If the object is beyond 2f, the image is between f and 2f, it's real, diminished and inverted. If we have an object placed exactly at 2f, the image is at 2f, it's real, it's the same size and is inverted. If it's between 2f and f for the object, the image is produced at a distance greater than 2f from the lens, it's real, it's magnified and it's inverted. And the final one, if the object is placed between f and the lens, so it's a lot closer, the image is produced on the same side of the lens as the object, it's virtual, it's magnified and it's upright. Now you do need to learn these key points, and this is the one that tends to be asked most in the exams in terms of what you're asked to draw. Now the final section